The concrete pad at the NRA Whittington Center in Raton, New Mexico, is baking under a relentless high desert sun. It is June 2016. A spotter stares through a massive scope at a white steel plate, perched on a ridge exactly 2,480 yards away. Nearly a mile and a half into the shimmering heat, the shooter stabilizes a custom rifle, settles his breathing, and presses the crisp match trigger. A deafening boom echoes across the canyon. For nearly 4 full seconds, there is nothing but silence and the low hum of the wind. Then, a sudden flash of silver appears on the distant steel, a first-round hit at nearly a mile and a half. This was the public birth of a ballistic revolution. The team dominating the leaderboard that weekend was shooting a highly engineered, purpose-built projectile that would soon rewrite the rules of extreme long-range shooting. This is the story of a cartridge born inside a ballistics laboratory. The .375 EnABELR, officially designated as the Engineered by Applied Ballistics for Extreme Long Range. This cartridge was conceptualized by legendary ballistician Brian Litz and mechanical engineer Mitchell Fitzpatrick. In the precision shooting ecosystem, it is recognized as a masterclass in modern internal ballistics, engineered exclusively to conquer extreme competitive distances while bypassing the physical flaws that plague traditional magnum cartridges. To conquer the longest distances on Earth, ballisticians had to completely reinvent the shape of the modern magnum. To understand why the .375 EnABELR exists, you have to understand the fundamental barrier of extreme long-range shooting: the problem of the overbore wildcat. By the mid-2010s, competitive long-range disciplines like the King of 2 Miles were pushing targets well past the traditional boundaries of military sniper systems. Standard cartridges like the .338 Lapua Magnum simply lacked the downrange kinetic energy and aerodynamic efficiency to reliably impact targets at 2,000 to 3,500 yards. To compensate, shooters relied on wildcat cartridges, custom rounds made by necking down massive parent cases like the .5 Anua 5 Gibbs or the .416 Rigby to hold .375 caliber projectiles. While these wildcats achieved blistering muzzle velocities, they introduced a catastrophic physical phenomenon known as velocity migration. When you combine a massive powder charge with a narrow barrel throat, it creates rapid carbon and copper fouling. This fouling increases friction and chamber pressure with every consecutive shot. In a standard tactical rifle, a velocity variance of 20 feet per second goes unnoticed, but at 2 miles, a velocity shift of just 15 feet per second alters the bullet's vertical trajectory by several feet, causing a clean miss. Extreme long-range shooters found themselves trapped in a cycle. Their cartridges had the speed to reach the target, but lacked the shot-to-shot consistency to hit it reliably. Furthermore, legacy extreme cartridges like the .408 Shatak possessed an overall length that rendered them single-shot propositions. When loaded with ultra-long solid copper bullets, the cartridges became too long to fit into any standard repeating rifle magazine. In 2018, the team at Applied Ballistics set out to solve this dual crisis. The engineering directive was precise: design a cartridge that matched the raw ballistic trajectory of the .4 boxed Shatak, eliminated the internal pressure instabilities of overbore wildcats, and fit cleanly within a standard repeating magazine. Litz and Fitzpatrick abandoned the practice of necking down massive vintage safari cases. Instead, they engineered a completely new case geometry from the ground up, partnering with Peterson Cartridge to manufacture the specialized brass. They shortened the case profile compared to the Shatak, increased the body diameter slightly to maintain an equivalent powder capacity, and integrated a sharp 30-degree shoulder angle. This specific geometry ensured a highly uniform, efficient powder burn. The resulting shape mirrored the proportions of the highly successful .338 Norma Magnum, scaled up to support heavy .375 caliber projectiles. The modern theater of operations for this cartridge is not a traditional battlefield, but the elite firing line of extreme competitive physics. The .375 EnABELR is entirely unique because its battlefield is the extreme competitive firing line. It was not built for military adoption, nor was it engineered to meet an army's logistical parameters. It is an elite, purpose-built instrument designed for civil precision matches, structural interdiction testing, and ultra-long-range aerospace data collection. Consider the cold impulse of extreme long range. At 2,500 meters, a traditional sniper round has entered the subsonic grave. The .375 EnABELR arrives with over 1,500 foot-pounds of energy, punching through wind shear that would steer other bullets completely off target, while the round is a civilian laboratory creation. Its development caught the immediate attention of defense contractors and specialized military research units. In modern sniper doctrine, standard calibers leave a distinct capability gap between the mobile, shoulder-fired .338 Lapua Magnum and the crew-served 30-pound .50 BMG anti-materiel rifles. The .375 EnABELR offers a unique operational solution. It packs the trajectory flatness and wind-defying performance of an anti-materiel round into a rifle platform light enough to be fed from a traditional box magazine and operated by a single marksman. In civilian applications, the cartridge has become a staple of elite extreme long-range competition. It is utilized by shooters who treat long-range marksmanship like an applied physics equation, using real-time Doppler radar telemetry, advanced ballistic computers, and custom-tuned actions to achieve consistency at distances once considered mathematically impossible. Breaking down the precise mechanical measurements and ballistic numbers reveals why this round outperforms classic military ammunition. The performance of the .375 EnABELR relies entirely on modern chemical and mechanical uniformity. This is where the cartridge separates itself from legacy magnums. Let us look first at the case architecture and operating pressures. The bullet diameter is .376 inches. The case length rests at 2.760 inches, which allows the overall loaded length to be optimized for standard large-action magazines between 3.65 and 3.85 inches, depending on seating depth. The brass itself is rimless and bottlenecked, constructed with an extra-thick web and sidewalls by Peterson Cartridge to endure repeated high-pressure firings using heavy large rifle magnum primers. It is engineered to operate safely at modern high pressures, typically staying within standard maximum limits of roughly 60,000 to 65,000 pounds per square inch to guarantee case longevity and shot-to-shot consistency. Unlike traditional infantry ammunition that utilizes jacketed lead-core bullets, the .375 EnABELR is optimized exclusively for lathe-turned, solid copper or solid brass monolithic projectiles. The primary projectiles developed alongside this case are the Berger 379 grain solid and the Berger 407 grain solid, alongside boutique offerings like the cutting-edge laser series ranging up to 425 grains. These bullets feature incredibly high ballistic coefficients, often crossing a G7 value of .450 to .500. The cartridge is typically loaded with slow-burning, temperature-insensitive extruded powders such as Hodgen H50 BMG or Retumbo. When we track a standard match load firing that 407 grain Berger solid monolithic bullet from a 30-inch precision barrel at sea level, the numbers are staggering. At the muzzle, it leaves at 2,800 feet per second, generating 7,087 foot-pounds of energy. By the time it crosses 500 yards, it travels at 2,437 feet per second, with 5,361 foot-pounds of energy, dropping just 47 inches. At 1,000 yards, it maintains 2,103 feet per second and 3,995 foot-pounds of energy, with 239 inches of drop and only 34 inches of wind drift in a 10-mile-per-hour full-value wind. At 1,500 yards, it flies at 1,794 feet per second, retaining 2,907 foot-pounds of energy. At 2,000 yards, it cruises at 1,515 feet per second, still packing 2,074 foot-pounds of energy. And at extreme range, out at 2,500 yards, it remains supersonic at 1,072 feet per second, delivering 1,462 foot-pounds of kinetic energy with a total drop of 2,492 inches. At the muzzle, the .375 EnABELR produces more than double the energy of a standard .300 Winchester Magnum. However, its true value is revealed past 1,500 yards thanks to the ultra-sleek profile of its solid copper projectiles. It retains velocity better than almost any round in existence. The bullet remains completely supersonic out past 2,600 yards when it finally enters the turbulent transonic zone, where the bullet encounters destabilizing shockwaves. The Berger solid bullet transitions smoothly without tumbling. In tactical terminal testing, the monolithic solid copper bullet acts as a pure kinetic penetrator, relying entirely on its immense remaining sectional density and linear momentum to punch cleanly through hard targets. Acquiring and fielding this laboratory caliber requires a highly specialized commitment to custom boutique rifle manufacturing. If you want to field a .375 EnABELR, you cannot simply walk into a local commercial store and buy a rifle off the rack. The market ecosystem for this cartridge is highly specialized, boutique, and requires a commitment to custom precision manufacturing. There are no mass-produced assembly line rifles chambered for this round. To shoot it, you must acquire a specialized large-scale precision action. The most common platforms are the Desert Tech HTI, a bullpup bolt-action system that can be converted via a custom barrel conversion kit, or custom builds using heavy actions from makers like BAT Machine or Stiller, paired with custom tapered barrels from makers like Bartlin or K&P Precision. These rifles routinely sport massive 30 to 34-inch match barrels with ultra-fast 1-in-7 or 1-in-8-inch twist rates to properly stabilize the ultra-long solid projectiles. Because this is an engineered cartridge supported directly by applied ballistics, components must be purchased from specialized precision suppliers. Peterson Cartridge manufactures custom, head-stamped .375 EnABELR brass in specialized batches. Desert Tech Munitions and select custom boutique reloaders offer limited runs of factory-loaded match ammunition. The financial reality check is steep. Factory-loaded match ammunition ranges from $11 to $14 per round. For hand loaders, after purchasing premium Peterson brass at roughly $4 per unprimed case, custom solid copper bullets at $2 per projectile, and large powder charges, the real-world operational cost settles around $4.50 to $6 every single time you pull the trigger. Standing side by side with the classic .338 Lapua Magnum highlights the true scale of this engineered round. To appreciate the immense scale of this engineered cartridge, it must be compared directly against the reigning king of conventional military sniper rounds, the .338 Lapua Magnum. The .338 Lapua Magnum fires a 250 to 300 grain jacketed lead core bullet at 2,750 feet per second, producing 4,200 foot-pounds of muzzle energy and dropping subsonic around 1,650 yards. The .375 EnABELR fires a much heavier 379 to 407 grain monolithic solid copper bullet at a faster 2,800 feet per second, producing a massive 7,087 foot-pounds of muzzle energy and staying supersonic past 2,600 yards. While the Lapua fits standard long-action magazines, has wide commercial availability, and features a manageable recoil impulse, the EnABELR requires specialized large box magazines, remains a boutique specialty round, and produces severe recoil that demands heavy chassis platforms. The tactical verdict is clear. The .338 Lapua Magnum remains an exceptional tactical military cartridge out to 1,500 yards. However, past 1,600 yards, it runs out of aerodynamic capability. The .375 EnABELR carries nearly 3,000 foot-pounds of energy at 1,500 yards, which means it hits as hard at nearly a mile away as a .338 Lapua Magnum does right at the muzzle. The EnABELR completely outclasses the Lapua in wind deflection and trajectory flatness, though it sacrifices affordability and barrel life to achieve it. The final verdict marks this caliber as a triumph of precision engineering over raw brute force. On the Precision Trade Incorporated evaluation matrix, we grade the .375 EnABELR across 4 critical pillars. For versatility, it receives a 4 out of 10. This is a single-purpose, highly specialized tool. It is far too heavy, expensive, and powerful for general sporting or hunting. It is engineered for one task: hitting targets past 1,500 yards. For logistics and affordability, it scores a 2 out of 10. Operating this cartridge requires custom hand-loading expertise or a reliance on niche boutique ammunition runs, demanding a massive financial commitment per shot. For ballistic efficiency, it earns a perfect 10 out of 10. The cartridge represents the pinnacle of modern ballistic architecture by eliminating velocity migration and optimizing case proportions for ultra-high ballistic coefficient solid bullets. It achieves a near-perfect balance of velocity, consistency, and stability. And for historical legacy, it secures a 7 out of 10. While it will never see mass production, the .375 EnABELR secured its place in firearms history by winning elite extreme long-range matches and fundamentally changing how custom builders design long-range case geometries. The final conclusion is clear. The .375 EnABELR is the future of extreme long-range design. It represents a profound shift away from primitive, oversized cartridges toward calculated, chemically and mechanically balanced systems. It is an instrument built for the pure ballistic purist, the competitive marksman, and the specialized defense researcher demanding maximum hit probability at distance. To review this data in an easily scannable format, download the comprehensive, printable digital ebook version of this episode, including high-resolution cross-section diagrams and full trajectory drop charts, by checking the description or podcast show notes below.